Okay. There are new students in the meeting. So our students, welcome these students. Don't go and message them. But from your heart, welcome these new students to the class. Okay. Now you are joining in the middle of the month. So should you make payments? Uh, like it's a half decision because now I have to talk with the physical institute. Now physical students are coming. Now physical also there's a free session and students will be coming for that. And I need to talk with the institute whether they will let them come freely because they have some rules and regulations. I don't think they will be able to give the students freely for 4 days because accelerated theory, every week we have two classes there are 4 weeks, so around 8 classes we are doing per month. Around 8 classes we are doing per month. And physical, both classes are physical. Online, both classes are online. And if you miss a physical class, let's say you couldn't attend for some reason, then you can join the online class. There is no I mean, if you're a physical student, then you can join online. If you're an online student, if you want, you can join physical. No issues at all. But if you are joining physical, you have to pay the fee to the institute. So what this institute, Faraday, right? You know it. People who are in Kandy, you probably know it. There were actually 12 or 13 students who are in Kandy, according to the Google form. So make sure if you can come physically, you should come physically. That is, if you can come physically, you should come physically. Don't settle down for online because physical is more interactive and more good than the online platform. Okay, so payments. Actually, 4,300 is the payment for a month. Now you might think this is too much. Actually, no, because other classes do 4 classes per month and it's around 3,000. So we are doing 8 classes. That's twice the work. That is why this is called accelerated theory. So that's why we have a small increment of payment of 4,300. So I think that's fair. I will tell you about the payment details later, right? After this free sessions are over, I'll tell you about the payment details later. Right. Second thing, raise your hands if you have done energetics before. You're 2027 students and some of you might have touched this unit. Raise your hands if you have touched this unit before. One. Others? Keep raising your hand. Keep it raised. Keep it raised. If you have done energetics before, raise your hands and keep it like that. Only one person. Two. Okay, one. Okay, one. Okay, one. So that means most of you are new to this unit. So energetics. People, this is the tute which you're going to get. You don't need to take printouts of this. You will get this tute if you join with our class. Or if you join with our class, if you make the payment and register with our class, then you will get this couriered to your doorstep. And also we have this inorganic. Inorganic is unit number 6. So energetics and inorganic both are starting. Energetics is starting today, so inorganic is starting next month onwards. So what about the previous units? We have completed unit number 1 and unit number 2 we have completed. We have to do questions related to it and more questions we have to do. Unit 3 we are around 85% completed. Small sections are available. We need to complete there and questions we have to do. Unit 4, we have completed again around 85%. So we have some amount of stuff to do in unit 4 also. So those things will be completed in this month in the rest of the 3 classes. So by that time, we will have finished unit 3 and unit 4 both. Okay. Now today we are going to start energetics. So please give your 100% focus. Right, give you 100% focus to the class. Now, I told you to fill a Google form to enter this class, right? Why did I do that? Why did I do that? It's a small effort. Filling a Google form is a small effort. If you really want to join and if you really want to cover this, you will have to fill that Google form. Because there are some students who are very lazy. They don't even like to fill a Google form. I don't want those students in my class. I want the students who are working and I want the students who want to get an A pass for chemistry. ඒකයි මම Google form එකක් දාලා ගත්තේ. හරි. Otherwise I would have shared the link normally to everywhere, every group I can share it. But I don't want those kind of students. හරි. So I want only the people who are working. So if you are a lazy student who doesn't want to work, I think you should leave the meeting right now. Because here we take students who are willing to work no matter what are the conditions. That is the rule in our class. You have to work, you have to interact, you have to do the homework, and you have to do exams. These 4 things you should be there within you if you are joining to our class. That's it. So take out this PDF. The students who join new and the class students, of course, have this tutored by you. It was couriered to you back, right? Right. Energy. In chemistry, you have 14 units. Chemistry, you have 14 units. In unit 1, we discuss about atoms. In unit 1, we discuss about atoms. Unit 2, we discuss how atoms are bonding together, how molecules are interacting with another molecule. So we are discussing about how molecules are arranging and their structure in unit 2, right? About molecules, we are learning majority of the time. It can be ionic compounds, it can be covalent compounds, there can be like, dative bonds and everything. We're going to discuss how atoms are interacting with another atom. Then unit number 3, we discussed how to do some calculations in the lab. Now, these are lab activities, calculating the number of moles, calculating the volume reactor titration. So everything, these are lab activities under unit 3. So basic calculations are included in this third unit. This is the base of all the physical chemistry coming in future. Unit number 4 is gases. This is where we learn about how gases behave and gases related calculations. So in gases, there are two sections. There is the theory section, which means Maxwell-Boltzmann distribution. And if you don't know these things, don't worry. Maxwell-Boltzmann distribution and, ideal gas equations and everything. The theoretical side is there. But also there are calculation sides in ideal gas equation. There are calculations related to Charles law, Boyle's law, and ideal gas equation, and those things are there. So there are two sections in unit 4. Then unit 5, this is related to energy. Energy is a beautiful topic coming under chemistry. It's a beautiful topic coming under chemistry. So this is the study of what are the energy changes that occur when a chemical reaction happens. So this falls under the big topic learned in physics, thermodynamics. Normally not in A-levels, but when you go to the university and all, you will see that thermodynamics. Under thermodynamics, thermochemistry is what you're learning in this unit, thermochemistry. This is the study of what are the energy changes that occur when a chemical reaction occurs. Right? When a chemical reaction occurs, what are the chemical energies released or gained during the chemical reaction, and doing some calculations regarding it. That is what we are going to do in this unit. Okay. You can see the energy is the capacity to do a work. In this unit, we are focusing on a very small section from thermochemistry. So, we will like we have only a small section to study under thermochemistry. So this unit is a small section of thermochemistry. When you go outside the syllabus, there's a vast majority of stuff you need to learn about this unit. But in A-levels, you are just framed into a small environment where you are learning the necessary things for your A-levels. So you can read here, scientists conclude that energy cannot be created nor destroyed. Is this true? Energy cannot be created nor destroyed. So that is the beauty of it. Recordings, yes. Now, when you are coming to our class, the thing is like you have to try your maximum in order to watch the class live itself. Without a proper reason, I won't give you recordings. I won't give you recordings. And even if I give you recordings, they will expire within 72 hours. Within 72 hours, they are going to expire in the website. So you have to make sure you watch the recording before 72 hours and complete it then itself. I'm doing this in order to avoid procrastination. Monkey one, the first rule I told you, if you want to join my class, you have to not be lazy. That's it. Like, literally. I don't want students failing in my class. If you really want to get an A, if you really want to work, then join my class. Otherwise, you can go out. Because more than money, what I want is people who are working. I want to see people get A's. I want to people improving themselves. I want to see people improve their marks by a weekly basis. So if you are a student who want to work, then you should stop in our class. If you are a student, if you don't want to work, you can clearly leave out of the class. That's it. Easy as that. Okay, now look at scientists conclude that energy cannot be created nor destroyed, meaning that energy always converts from one form to another. Isn't that true? Isn't that true? You drop this marker on the floor. I won't drop it. It's going to there you go. What happens? When I'm holding it like this, it's going to be potential energy. When I'm going to drop it, it's going to convert into kinetic energy, right? And when it falls down, it turns into many types of energies. What are the energies? Sound energy, heat energy. By tapping like this, it's going to form heat energy, and different other kinds of energy it's going to form. So it's going to turn from one type of energy to another type of energy. So I won't be going deep into this topic because this is something which you learn in physics, not related to chemistry. Then you can read that, meaning that energy always converts from one form to another. In chemistry, majority of the times we can see that when a reaction occurs, it will liberate heat or gain heat. Wait, what's heat? What's heat? What is heat? What is heat? Heat කියන්නේ මොකද්ද? Now energy, I told you, transferring from one place to another. Energy transferring from one place to another. What is heat then? Heat is the transfer of energy from one body to another body, which are at different temperatures. Doesn't that make sense to you? Doesn't that make sense to you? In all of us, you have done this kind of experiment in your science book where you hold a metal rod. You hold a metal rod under a Bunsen flame, in one end, and you're going to hold your finger here. So now what happens? That side is getting heated, right? That side is getting heated and the temperature is going to increase, and that energy is going to spread throughout the metal rod. And then in your finger, you're going to get that heat. So this is one example of heat. This is one example of heat. It's a method of energy transfer from one place to another place. Okay. Thermochemistry is the study of heat change occurred with chemical reactions. Now you know different type of reactions in our syllabus, right? Some of the reactions you have understood. For example, I2 plus S2O3 2 minus. This is a famous chemical calculation reaction. So even this reaction has a certain energy change. It could be either gaining energy or either releasing energy. One of these two. There are some situations which energy change does not happen. That's a different story. My idea is some reactions, majority of the reactions, either they gain energy or release energy. So there are two things, gain energy or release energy, right? Okay. So when a chemical reaction releases heat, we call it as an exothermic reaction. There you go. That's the first thing you need to know. What is exothermic? When a reaction occurs, it's going to release heat. When a reaction occurs, it's going to release heat. So you can write this down. If you have the tute near you, you can write this down in that space. Look at this reaction, sodium hydroxide and HCl. This reaction, people, the products would be NaCl plus H2O, right? It would be NaCl plus H2O. Then, people, now what is this? This is an energy diagram. This is an energy diagram. We are just plotting how the energy is going to change when the reaction is occurring. For example, the initial energy. Now this is the y-axis. The vertical line is going to be the y-axis. So that is going to represent energy. So I'm going to write sodium hydroxide plus HCl here. I'm going to write sodium hydroxide and HCl here. Then when the reaction happens, it's going to release energy, right? It's going to release energy. Now let's assume the value here is 500 joules. The energy of the reactant, sodium hydroxide and HCl, is going to be 500 joules. 500 joules of energy is stored within this system. Isn't that right? 500 joules of energy is stored within this system. So when the reaction happens, you get the products. Also, you're going to get some energy released. Why? How can you tell that? People, when you react sodium hydroxide and HCl together, what's going to happen is it's going to increase the temperature of the beaker. Again, it's going to increase the temperature of the beaker. So what does that mean? It's releasing energy. It's releasing heat. It's increasing the temperature. The reaction is exothermic. Also, To release heat, people, these reactants should lose heat, lose energy. Losing energy means it will go down, right? I mean, it'll drop something to around 200 joules, maybe. I'm not telling the exact values. These are not exact values. These are just imaginary values. Maybe drop down to 200 joules. Maybe drop down to 200 joules, and now you can write the products here. Sodium chloride plus H2O. So now you can draw an arrow like this. You can draw an arrow like this. And then you can tell, okay, energy is released now. The excess energy which was here is released now. The excess energy is released. You can write this equation and draw this and also leave some space to write a sentence. First of all, you can write this and then draw that and then raise your hands once you're done. Raise your hands once you're done writing. So being in Kandy, why are you voting for online? This is a once in a lifetime opportunity to come to my physical class. There's AC and there's a good environment there. I mean, very good learning environment. The classes which I went back then didn't have such kind of facilities there. There are cameras and everything is there. So try to come physically. It's a nice place, Faraday. It's a nice place. Try to come physically. If you are in Kandy, don't lose this chance. Now, let's say Thursday afternoon you can attend and Saturday you can't attend. Fine. Saturday join online and other day come physically. No issues. Raise your hands once you finish writing this. හරි ළමයි ඉක්මනට ලියන්න. හරි every one of you raise hands once you finish writing. I want everyone to be active in the meeting. හරිද? The people who are not responding, I'm going to remove from the meeting. හරි ඉක්මනට come on quickly. Keep raising your hands, don't put it down. හරි nice. Very good. Yeah, 200 joules is the energy of the product. And don't take this very seriously. These are not real values. I just gave them for reference to just tell you the meaning of this. So how much energy is released? 500 minus 200, 300 joules, right? So these are exothermic reactions. So you can see some reactions are liberating heat and some reactions are gaining heat, right? The next one only gaining heat. So right there under this one, write it. Above reaction is releasing heat. Above reaction is releasing heat, which increases the temperature of the beaker. Which increases the temperature of the beaker, and full stop. Therefore, the reaction is exothermic. Hurry. Nice. Next one. When a chemical reaction absorbs heat, we call it endothermic reaction. So under that, we can write another reaction there. So give me some ideas to study chemistry, like time slots and how to practice. I tell it at the end, okay, Sharfa? I'll tell it at the end. I will finish this section for today and then I'll teach you that at the end. And also there's something special about our class. Harry, there's something special about our class. They are doing the class in Pomodoros. Now, sometimes I won't do. Sometimes I won't, but majority of the times I do. So can you tell that point again? Sure. Above reaction is releasing heat, which increases temperature of the beaker. Above reaction is releasing heat, which increases temperature of the beaker. Therefore, the reaction is exothermic. So if something releases heat and it heats up the beaker, that means the reaction is exothermic. Exothermic. We are doing the class in Pomodoro. So what's the Pomodoro? It's a study method. It's a study method where you study for 25 minutes and then you give yourself a 5 minutes rest without using your phone. I mean, you can walk around and then come back, have some refreshment and then come back. So again, study for 25 minutes, 5 minutes break, 25 minutes, 5 minutes break, 25 minutes, 5 minutes break. And what's the speciality? We are doing the class in that way. We are doing the class for 25 minutes and then we are giving you a 5 minutes break. 25 minutes, 5 minutes break. What does this do? Increases your focus and increases your attention. And then you can stay even for longer times in the class. So we are going to do the class like that today. So 7:23, we started at around 7:05. So I'll give a Pomodoro break, 5 minutes break at 7:30. Okay. Hurry. There the next reaction you can write. Nitrogen plus oxygen goes to 2NO. This reaction is absorbing heat. This reaction is absorbing heat. How do I know it? How do I know it? Mehema, you have to do it practically and see. Otherwise, you can't tell. Like, for example, there are some aliens. There are some aliens, and that alien country, alien world or somewhere, you find a reaction like this, and even they don't have English letters. Okay, they don't have English letters. They have something like square plus circle goes to triangle. So there's something like this, and they're asking you to write whether this is endothermic or exothermic. You can't. You can't. Not even me. Like not even the professor of biggest professor of chemistry in Sri Lanka can't tell that. Can't do that, right? I mean, we can't look at a reaction and predict whether it's endothermic or exothermic. Can't do. We have to do it practically and see. We have to put a thermometer and see if the reaction temperature is increasing or decreasing. Then only we can tell, okay, this is exothermic, this is endothermic. But these things we have done previously. I mean, scientists have done, students also have done this. We can tell like whether reaction is exothermic or endothermic. So this reaction is endothermic. This reaction is endothermic. So that means what? We can write the reactants below now. Why reactants below? Energy is less. Products, NO. NO is the products and NO is on top. And then N2 plus O2 is at the bottom. That means energy increase, right? Energy increase, which will absorb heat. Which will absorb heat. For example, let's say 100 joules here. And here it's going to be 300 joules. So what is the amount of heat absorbed? What is the amount of heat absorbed? Come on, tell me. What is the amount of heat absorbed? Drop me a message. What is the amount of heat absorbed? If 100 joules is the initial energy and 300 joules is the final energy, what is the amount of heat absorbed? 200 joules. Give me a second. One person wasn't added to the group. Yeah, 200 joules, right? Okay, very good. Everyone tells 200, so that's correct. Hare. I hope that student joined to the class. So now when drawing the diagram, should we write NO as a product or 2NO as a product? It's better to write 2NO as a product. Now we are going to discuss these things later. Harithan, this is just an example. This is just a rough example. This is not a correct diagram even. Just a rough example. So 200 joules is absorbed, right? 200 joules is absorbed. Hari. Then write there a statement. Write there a statement. Above reaction is absorbing heat. Above reaction is absorbing heat, which decreases temperature of the beaker. Which decreases temperature of the beaker. Which decreases temperature of the beaker. Therefore, the reaction is endothermic. Therefore, the reaction is endothermic. Hare. Day 6 stuff done. I wanted you to understand what is endothermic and what is exothermic. Hare. I wanted you to understand what is exothermic and what is endothermic. Right. තේරුණානේ? හරි. superior තේරුණා. Right. Very good. Now, have 5 minutes break. So 7:28, I'll be starting at 7:33. 7:33 I'll be starting. If you want, you can just walk around and come back at 7:33. Don't take your phone in hand. Hurry, don't take your phone in hand. That's because there's a scientific reason for that. I'll tell that later. Have a break and come. 5 minutes, okay? Don't look at a screen. Just walk and come. Relax. Take it easy. Chemistry is not hard. Life is easy, Hami. Like, really? Life is easy. Just walk and come. Next topic is systems. Oh, you were not added. I told you to drop a message if you are not added. I might have missed you. I'm really sorry about that. Yes, 7:33 actually, Faza. In my watch, it's 7:33. Now only 7:34. Okay, now only 7:34. Right. Let's start. What does the x-axis represent? X-axis එකට අපි කියන්නේ reaction coordinate කියලා. We are going to learn that later. Now don't think about it. X-axis is called the reaction coordinate. We just write the reaction. It doesn't represent anything actually. It doesn't represent anything. Hurry. Raise your hands if you're there in the meeting now. Raumat dala awal. Raumat dala awanang raise your hands. Come on if you're there in the meeting. Ah, nice. Go. Atusan everywhere. Be active, huh? Be active and be happy. No sleeping in the class. Hurry. සමහර කට්ටිය නිදි අත උස්සන්නේ නැහැ. හරි, some people are not raising hands. Come on. Okay. Okay, come back. System. What's the system? So, system is a place where the reaction is taking place. This is the boundary of the reaction. In chemistry, we tell system could be a beaker. Right? System can be a beaker. System can be a glass box. Right? System can be anything that is where, I mean, the reaction is happening. Reaction should happen there, and that's a system. So there are three kinds of systems. There are three kinds of systems. There are open systems, there are closed systems, and there are isolated systems. So we'll go through them one by one. Look, to analyze energy changes associated with chemical reactions, we must first define the system or the specific part of the universe that is interested to us. ඒ කියන්නේ from the whole universe, the place where the reaction is happening, that is what we care. Not anything else. Not about what you are going to eat tomorrow morning. Not about how your friend will, where your friend will go tomorrow. Not anything. We are interested only in the place where the reaction is happening. So that is the part of the universe that we are in interest of. So that's a system. Hari, that's a system. For example, in an acid-base reaction, the system is the beaker containing 50 milliliters of HCl and NaOH. The rest of the universe is surroundings. Highlight that. The rest of the universe is surroundings. So these are basic English words, right? I don't need to highlight them. Somebody might be thinking like that. But it's a word we use in chemistry. Surroundings කියන්නේ without the system, other things. So there are three types of systems: open system, closed system, and the next page, isolated system. Hari, isolated system. So open systems, matter and energy can be exchanged with the system. Example is a water cup open to the outside. Why is that? Now the thing is, when a reaction is happening inside this open system, matter can be exchanged. Isn't that right? Matter can be exchanged. There's a bird flying over the top and then the bird drops something into this. So matter can be exchanged. These are called open systems. These are called open systems. That means matter can be exchanged to outside. Also, energy can be exchanged to outside. Neither. We can heat this. We can heat the beaker. We can heat the glass of water. We can put it in a microwave, or we can put it in an oven, or maybe somewhere else. We can just heat it, right? We can keep it on a hot plate also. We can just heat it. So that means energy and matter can both be exchanged. So draw it like this. Whatever. Put a bird. I'll draw it like this. So matter can be exchanged. Matter exchange and energy exchange. So these kind of systems are called open systems. Easy to study. The word is very easy. Open systems. Right? Now this is the thing, you're not doing this practical in a place where birds are flying, but still it's called an open system. I just wanted to make it, little bit entertaining. In Sinhala literature, you had this, right? සාල්ලේ කලාලා පාතට බානා කෙනෙකුන් මෙන් වර්චස් පිටක් හෙලයි කියලා සිංහල පොතේ තිබි මතකද? O level සිංහල book in සතරකම් මන්ත්‍රණය. The first part, I guess, in Sinhala literature. People who have done might know it. Right. Raise your hands once you finish drawing this. Raise your hands once you draw this. So at the end of the class, I'll be giving you some study plans and study methods and how to improve your marks and what to do with chemistry. There are only 1 year and 6 months. Don't forget, 2027 August, you will have your exam. Hurry, come on, everyone, raise your hands. Don't be lazy. Until the end of the meeting, I want you to have your energy. Hurry. Now 7:33, we started the class. We're going to give you a break at 8:03 again. 8:03 नहीं 7:58, right? 7:58. Come on, raise your hands, everyone. Be active. Hafsa Rizan, Muhammad Akmal, Nishan, Kader, and Samudika, Shada, and Sharfa. Everyone, come on. Be active. Hurry, right. Very good. Very good. The next topic, closed system. Next topic is closed system. Hari lamai. Closed system කියන්නේ now you don't let anything fall from the top. Now what you do is you cover it with a lid. You cover it with a lid. Now matter cannot exchange. Now the bird is going to come and sit here and wait. Bird is sad. Why? He can't put anything inside now. The bird is sad. Bird name is like a duck or something. But you can heat. But you can heat. But you can heat. Matter cannot be exchanged, but heat can be exchanged. Matter cannot be exchanged. Matter cannot be exchanged, but heat can be, energy can be exchanged. Energy can be exchanged. Energy can be exchanged. So these kind of systems, we call them closed systems. When you finish writing Lamai, raise your hands. Hurry. Okay, maths karna kattiya to usanna. People who do maths. Others, put your hands down. People who do maths, raise your hand. People who do maths, raise your hands. Only maths, huh? Maths is right. Dekam karan nahi kawurut ne. Only four. Four. Hafsa, Risan, you do maths? No, no, ne. Only three. Okay, three, right? Uh-huh. Okay. The thing is, in our 2027 class, there are around 15 students all together. All of them do bio. Can you believe that? Right? All of them do bio. All of them do bio. Hurry. Can I erase this? Next one. Next one. Isolated system. Isolated system. Okay. By placing the water in a totally insulated container, we can make sure no energy and no matter can be exchanged. Totally isolated system. Those are called calorimeters. Those are called calorimeters. No no energy is exchanged and also no matter can be exchanged. So you can put a vacuum here. So this is a vacuum. And this is the system. So this is an isolated system. No energy can be exchanged through this vacuum. No energy can be exchanged through this vacuum and also no matter can be exchanged through this vacuum. So it's completely closed from the outside. Completely closed from the outside. So these kind of systems, matter cannot be exchanged and energy also cannot be exchanged. We call them isolated systems. We call them as an isolated system. We call them isolated, completely isolated from the surroundings. Draw this down and raise your hands once you're done. Hurry. Then next one. System have two main kinds of properties. So there are two kinds of properties in a system. First one is microscopic properties. So read that part. Properties of a system which should be measured by indirect methods such as kinetic energy, speed of atoms, molecules, and in a closed container. It makes sense, right? I mean, you have a bottle of water near you. So in this water bottle, there are trillions and quadrillions, and like I can't even tell that much amount of water molecules are there. Can you measure the speed of a water molecule just by looking at this? I mean, can you? You can't, right? So these are microscopic properties. That word makes sense. Microscopic. You can't measure them directly. You can't measure them directly. So what you do? You should have another method to measure them. So indirect methods. Some now in unit 4 we are going to learn. We are calculating mean square speed. So mean square speed is just the average value. Mean square speed just the average value. So something like that. We just calculate something like, by an indirect method. By an indirect method we calculate. So those kind of properties are called microscopic properties. The second one is macroscopic properties. Properties of a system which can be measured directly. For example, pressure. How to measure pressure? How to measure pressure? Barometer. We can set a barometer. Then volume. Volume also can be measured. Then what? Temperature can be measured. Thermometers. Concentration also can be measured. Then density can be measured. Viscosity can be measured. Viscosity you will learn that. What is viscosity? Okay, what is viscosity? You might not know what is viscosity because you are a 2027 student and you haven't done physics last parts. So viscosity is a nature of some liquid. For example, it is, now think it like this, there is a board. There is a board. There is a glass board like this. Glass board. Glass sheet. Let's say glass sheet. You're putting honey on this side. You're putting honey on this side. And this side you're going to put water. So who's going to go down first? Of course, water, right? Water will go down first. But honey is slowly dripping down. So honey has a larger viscosity. It's a property of a liquid. It's a property of a liquid. So it can be measured. It can be measured by using an equation. You're going to learn that in physics later. So we don't have it in chemistry. So viscosity is a property. Surface tension next on. Surface tension also. Refractive index and color. These things we can, observe and tell, or either do some calculations and tell. We can directly tell it. Macroscopic properties can be subcategorized into two more types. Now, macroscopic properties have two types. First one is going to be extensive properties. The second one is going to be intensive properties. Extensive properties can be the properties that depend on the amount or size of a system. Again, depends on the amount or size of a system. What does that mean? What does that mean? Now, think will you, there is a basket of balls. There is a basket of balls. All these balls have equal volume. What do I say? All these balls have equal volume. All these balls have equal volume. So I'm going to tell you the examples of extensive and intensive properties through this ball basket. What is intensive now? What is intensive? Intensive can properties that do not depend on the size of the system. Now what you're going to do? You have another small basket like this. You're going to put this inside and then you're going to take it out. And then now you have a set of balls. You have a set of balls. You have a set of balls, right? Okay. Now, we are going to measure the mass of it. We're going to measure the mass of it using a weighing scale or something. We are going to measure the mass of it. The mass is going to be, let's say now this has a total mass of 10 kilograms and that has a mass of, let's say 100 grams. That has a mass of 100 grams. We are going to do this again. Again, we are going to do, and then again, when you take back people, now there's 2 extra balls now. There are 2 extra balls, maybe 3 extra balls. Now the mass has a little bit increased. let's say 120 grams. Now the mass is increased. So mass is a intensive property. Mass is an intensive property which depends, right? No, sorry, extensive property. It depends on the amount of size of the system. Now this depends. How much amount of balls you take, it's going to change the mass. How much amount of balls you take out, it's going to change the mass. So that is an extensive property. So this system, the mass is an extensive property. So what is intensive? Intensive can maybe density. Density. You know what is density? Let's say the total mass is 10 kilograms and the volume of this system, I'll say 10 cubic meters. 10 cubic meters. So what is the density of this system? Density is equal to mass over volume. Mass over volume. So 10 kilograms divided by 10 cubic meters. That's going to be 1 kilogram per cubic meter, right? Isn't that correct? Isn't that correct? That's correct, right? Okay. Now I'm going to put a basket again, just like the previous case, and then I'm going to take another amount outside, right? I'm going to take another amount outside. Now this one is the mass thing. And another amount outside, let's say like this. Let's say like this. Now I'll tell now the volume I have taken. The volume I have taken is going to be 1 cubic meters only, right? 1 cubic meters. So the density, will it be same? Your answers, tell me, you tell me, will the density of the system be same? Now these balls, think like these are very microscopic and very small. Harita, these are very small balls. Tell me, will the density be same? It will be same, right? Density will be same. No matter what is the volume you take out, the density will be same. That means the mass should adjust. The mass should adjust according to that. That means this mass should be 1 kilogram. 1 cubic meter should contain 1 kilogram, definitely. 2 cubic meters should contain 2 kilograms. They are both going to adjust. They are both going to adjust. So these kind of properties are called intensive properties. These kind of properties are called intensive properties. So this is just an explanation for you to understand. No need to write this. I hope you understand what I'm trying to tell you. The mass and all which depends on the amount of substance are called extensive properties. Meanwhile, intensive properties are the substances which are not going to change. Even if we take a large amount or a small amount, it's not going to change. That property will remain constant. So example, right now, go to your kitchen and don't go. Go to your kitchen and then you take a hot cup of water. You measure the temperature. Let's say 27 degrees Celsius. Now 27 when that's room temperature. Let's say 50 degrees Celsius. 50 degrees Celsius. Even if you take small portion of it out and even measure the temperature of that, it's still the same. Same system. Temperature is going to be same. Unless you let heat go out of the system, it's going to change, of course. But if we consider equal temperature during this time period, the temperature, no matter what amount you take from that glass of water, it's not going to be different. So temperature is also an intensive property. Temperature is also an intensive property. So there you see. So these kind of things are intensive properties. Then people, part A. Number 2 part A එකක් තියෙනවානේ. We can categorize intensive properties. We can categorize intensive properties. We can understand intensive properties by using these tricks. The first one, everything that contains per word, per mole, per cubic centimeter. So these kind of things definitely will be what you call intensive. For example, per mole, per gram, per cubic centimeter, per square centimeter. It becomes an intensive property because per per unit volume. So whatever the volume you take out, it doesn't change. It's not going to change, right? So they are right there. Per mole, per cubic centimeter, per cubic decimeter, everything that has this per. Let's put it like this. Per mole, per cubic centimeter, per cubic decimeter. This can be anything. Grams per mole. Anything. Grams per cubic centimeter, liters per cubic centimeter, whatever it is. Any property that contains this per part will be what you call intensive. This will be intensive. Then part B, everything that contains molar. Everything that contains molar. Molar කියන්නේ per mole ඉතින්. හරිද? For example, now 2027 students, you know molar volume. In gases, we learned molar volume, right? In molar volume, what does molar volume means? What does molar volume means? The volume per mole, right? Volume per mole. So molar volume කියන්නේ the volume occupied by one mole. So whatever the type of gas sample you take, it's going to be per mole. It's going to be per mole. So they are right. The best example is molar volume, right? Best example is molar volume. Can write there molar volume. Right? Molar volume. So these are also intensive. These are also intensive. Then the next page, density, specific heat capacity, boiling point, melting point, surface tension, temperature, and whatever you can think which doesn't change, you can apply into the part C. හරි? එතකොට මට කියන්න ඕනේ part A and part B molar values also the what you call per values which contain in that what you call unit is going to be same whatever the type of whatever the place you're going to take it from. Hari, it's going to be same. So the density is not going to change, right? From the system, no matter if you take a small amount or large amount, it's not going to change. Hari. Now, again, have a 5 minutes break. Then බලන්න meeting participant count decrease to 19. මොකද්ද මේකෙන් කියන්නේ? Now, what does this mean? There are some people who can't sit in one place, look at a screen, and then write this stuff, and then understand this stuff. So if you are still in the meeting, that means you can do this better than them. They've already lost. They have already lost. I don't think I have any bad side from, I mean, when I'm teaching like this, I don't think my teaching is bad. Of course, there are a lot of students praising it. I don't think you will see something bad here while I'm teaching. I mean, literally, I mean, you think I'm good, right? Just tell me, come on. You tell me right now whether this session is useful for you. Tell me. Drop a message. New students. Hari? ඉන්න කට්ටිය කියන්න එපා. May others. Tell me. Did you understand today's session? Better than another class. Better than what you went before. I want you to drop me a message. Just a small message. Yes. And it's a capital yes. එතකොට yeah, okay. Enough. Yes. හරිද? එතකොට ඒක මගේ සයිඩ් එකෙන් වැරද්දක් නෙමෙයිනේ. So it's a issue from their side. ඒගොල්ලන්ගේ සයිඩ් එකෙන් issue එකක් මට වැඩක් නැහැ. හරිද? එතකොට ඒ කට්ටියගේ issue එක ඒ කට්ටියගේ issue එක තියෙන්නේ it's something they have to fix and you have to know that you are here in order to cover these things. So that means you're ahead of them. You are ahead of them. And that means you have a vision, you have a goal. So don't leave the meeting until the end. Don't let me judge you. Don't let me judge you. So if there's a reason, if you really want to leave, I mean, maybe another class, now one person told she has a class at 8. So acceptable. But any other reason, because you're lazy or because you have to watch a cricket match or something, now there's World Cup going on, I think now, right now. I don't know. You can leave the class and then maybe you don't join again to my class. එන්න එපා. හරිද? ගියාම එන්න එපා. වැත්ත බලා දෙන්න එපා. ගන්නෙත් නැහැ. හරිද? එහෙම එකක් නම් එන්න එපා. Like if it's really necessary, then you can leave. හරි? Have a 5 minutes break. Now the time is 7:59. I'll start the class at 8:04. You're a he. Okay, sorry. Nishan Kader. Yeah, part A, B, and C belongs to intensive properties. So will the class time be changed because its fasting days are coming and we have night prayers? I'll discuss with you students. You only have to decide and tell me. Mama poll එකක් දානවා and you have to decide. Okay, now which time you have to pray and how much time you're praying. So I will have to reduce that class time and then do accordingly because majority of you are Muslims here. Majority and around 80% of you are Muslims. So I will have to give you time for such kind of things. So yeah, I will discuss it with the students and I'll decide it after that. This is a democratic class. It's a democratic class. So you can make decisions sometimes, not always, but you can make decisions sometimes. Yes, we are going to get recordings. Okay, 1 minute more. Hurry. So our third Pomodoro session begins now. Okay, raise your hands, everyone in the meeting. Hurry. Enthalpy. Now you have to give some focus. Now only things are starting to get a little bit complex, right? Enthalpy, that's a new word. What is enthalpy? Hurry. To quantify the heat flow into or out of the system in a constant pressure process. Highlight that for total statement, highlight it. Total statement highlighted that constant pressure process should be there. To quantify the heat flow into or out of a system in a constant pressure process, chemists use a property called enthalpy represented by the symbol H. Represented by the symbol H. At constant pressure, the heat change occurred is equal to the enthalpy change. Under constant pressure, at constant pressure, heat change occurred is equal to the enthalpy change. Enthalpy is an extensive property. Enthalpy is an extensive property. So it depends. Sorry, it does not depend on the system. I mean, whatever the place you check, its enthalpy is going to be same. Next one. It is impossible to determine the enthalpy of a substance directly. We can only calculate the change in enthalpy. Therefore, enthalpy is a relative quantity and not an absolute quantity. Something very strange. I mean, really strange. Impossible to determine enthalpy of a substance directly. We can't determine the enthalpy of a substance. We cannot do it. Enthalpy කියන්නේ මොකක්ද කියලා මම simply නිකන් if I told it what is enthalpy, it is the energy that you have in a molecule. H2O has a certain enthalpy, the energy in the bonds, how electrons are arranged, the speed of electrons, kinetic energy of electrons, all of these combined together, we tell, okay, hydrogen has a enthalpy. We can never find that enthalpy. We will never be able to find that enthalpy ever in our life. What we can find is the enthalpy change. When a reaction is happening, for example, A plus B goes to C plus D. We can never find the individual enthalpy of this A. We can never find the individual enthalpy of B, even C, even D. We cannot find it like that. We can only find the enthalpy change. You call it delta H. Enthalpy කියන්නේ මොකද්ද? What is enthalpy? Enthalpy is the total amount of energy stored within the molecule. Yani within the molecule එක ඇතුලේ තියෙන energy එක. Enthalpy change කියන්නේ the enthalpy of the products, the total enthalpy minus final enthalpy. So now I'm telling you enthalpy of products minus enthalpy of reactants. Now you might be wondering now, this is from your point of view. You might be asking, you told me that enthalpy cannot be measured directly. So then, how are we going to calculate the product's enthalpy one by one, and then calculate the reactant's enthalpy, and then subtract and calculate? How does that work? Questions. That's a question. That's a nice question, which I asked myself. You didn't ask it. That's a nice question. You will get the answer for that within the next 1 hour. You will get the answer for that within the next 1 hour. So stay curious about that. For now, we say, okay, enthalpy of products minus enthalpy of reactants. That's going to be what? The enthalpy change. That is going to be the enthalpy change of a reaction. So there in the table you have it. What is that absolute relative thing? What the absolute relative කියන්නේ? What is absolute? Okay, now clear up your mind and focus. Okay, clear up your mind and focus. What is relative and what is absolute? The enthalpy there, you understood what is enthalpy and the change in enthalpy, how to calculate. Okay, enthalpy word is done. The next word, relative quantity and absolute quantity. Relative quantity and absolute quantity. Read that again. It is impossible to determine the enthalpy of a substance directly. We can calculate the change in enthalpy. Therefore, enthalpy is a relative quantity and not an absolute quantity. Something which cannot be measured directly. Something which cannot be measured directly. Again, is something which doesn't have a zero value. Something which doesn't have a zero value. Those are called relative quantities. The quantities which has a zero value, for example, mass, temperature. Temperature only Kelvin. Celsius is not an absolute quantity. Celsius is not an absolute quantity. Celsius is a relative quantity. Only Kelvin is absolute quantity. I will tell you about these things later once I finish energetics. This is not something important for energetics, but this is a question pattern that I have seen in certain term test papers. And I have included them in the 2026 revision papers also. I have included that. I just wanted to tell you this fact. You have to know enthalpy is a relative quantity and not an absolute quantity. Okay, තේරුම් ගන්න. I'll explain it to you later. I'll explain it to you later. Then the next one, enthalpy has units kilojoules per mole. Kilojoules per mole, which is interesting. Enthalpy change can be defined as the enthalpy of products minus enthalpy of reactants. I know there's one more thing I need to do to you. Enthalpy is a intensive property. Correct it. එතන කොහේ හරි තියෙනවද මේ extensive කියලා හිතේ? Enthalpy is an intensive property. Intensive property. It does not depend on the amount of substance. Hari? Correct it as intensive. It's a mistake. So it contains this per mole part. So per mole part tells you that it's a intensive property. Hari. Enthalpy can be defined as the enthalpy of products minus enthalpy of reactants. Then you have to write the equation. Delta H is equal to enthalpy of products. You can put this sigma sign if you want. Delta H is equal to sigma enthalpy of products minus sigma. That means the sum. What does this tell? Sum. Sum of enthalpy of products minus sum of enthalpy of reactants. So you are going forward with a lot of questions in your heart. What's the first question? We can't measure we can't measure the enthalpy of individual components. So how can we calculate delta H? That's the issue. That's a nice question to have. Keep it in your heart for now. Okay. I'll answer that within the next 1 hour. Right. Next one. Next topic. Endothermic reactions have positive enthalpy changes. Why? Why positive enthalpy changes? Why does endothermic reactions have positive enthalpy changes? Now, what is enthalpy here? Kilojoules per mole, right? It is the energy of 1 mole of substance. Just 1 mole of substance. Energy of 1 mole of substance, not the total energy. We don't care how much you have. Maybe you can fill H2O molecules until the sea and the oceans. You can fill water now. Water in the oceans. The total energy of water molecules you can calculate, right? We don't care about that. We only care about 1 mole of water. That's it. Which is going to be a constant everywhere. So that's why I told enthalpy is an intensive property. So kilojoules per mole. We are interested in the energy in 1 mole. So it's just like energy, in the beginning, we did endothermic, exothermic reactions, and then we discussed how energy is going to vary, and we told endothermic reactions are gaining energy, and exothermic reactions are releasing energy. So according to this equation, you can tell, for example, write this reaction. The reaction which we wrote before, N2 plus O2, going to be 2NO, right? Going to be 2NO, right? So the enthalpy of products minus enthalpy of reactants, if the product's enthalpy is larger than the reactant enthalpy, of course it's going to be positive according to this equation. Isn't that correct? Endothermic reactions, if you draw this diagram, which I wrote before, initial energy, it's going to be N2 plus O2 energy, and then energy is going to increase. It's going to form NO, which is going to be endothermic. So it's going to absorb energy. Absorbing energy to go to a higher level. That means products have a larger energy. For example, 1000 minus 500, which is plus 500. This plus sign is what we are interested. So endothermic and gaining energy, that means the symbol is going to be positive. Symbol is what we are interested. So delta H is going to be positive here. Right? For endothermic reactions, delta H is positive. Delta H is positive for endothermic reactions. For endothermic reactions, delta H is positive. Draw this down and raise your hands once you're done. You write this reaction, draw this diagram, and then you write delta H is positive because products are larger than reactants, right? Products are larger than reactants. So here, make sure you put enthalpy. Make sure you put enthalpy. Alright. So exothermic reactions of negative enthalpy changes of නෙමෙයි have. හරි එතන correct කරන්න exothermic reactions have negative enthalpy changes. So I'll discuss about this class time in the group. Okay. Now මෙහෙමනේ. Now you can tell class times if you are joining to our class. Then make a free sessions. Now these are 2 free sessions. Saturday night also. Sunday night නෙමෙයි. Sorry. Saturday night, no, Sunday night. We have the class Sunday night because students told they can come on Sunday better than Saturday. So Saturday votes are lesser than Sunday votes. So Sunday people, Sunday is a good day for 2027 class. That's why we changed it to Sunday night. So Sunday night, 7 p.m. we have our next class for this week. And those are the 2 free sessions. So if you are continuing after that, then only you have to make a half payment. You have to make a half payment. If you are continuing after that, if you're not continuing, you can just go away. You don't need to make a payment for these 2 free classes. But if you are continuing, then you will have to make a half payment for the class. This is what I wanted to do because physical classes, they will take money from them. So it's unfair, like physical students are making payments and you are not, that it's an unfair thing, right? So that's the reason for that. And yeah, exothermic reactions of negative enthalpy changes. So exothermic reactions, for example, NaOH plus HCl will go to NaCl plus H2O. So there, the enthalpy of the initial sodium hydroxide plus HCl is higher than the products, right? Products are at the bottom. So NaCl plus H2O. So it's going to drop down like this. It's going to drop down like this. And according to this, we can tell delta H is going to be negative. Why is that? Initial enthalpy is larger than the final enthalpy. For example, let's say this is 100 and this is 300. So 100 minus 300 is minus 200, right? Final minus initial. Products minus reactants. So we can tell final minus initial 100 minus 300, which is minus 200. So delta H is going to be negative if the reaction is exothermic. Hare. Now I'll take 5 minutes to explain you what I have done in the class and what are the most important things. Hare? Okay, listen, don't write anything. Look at me. Face. Look at my face. Okay, right. First thing. First of all, we learned what? What did we learn first? We discussed what is energy, which is not much important for chemistry. What is energy? You just don't know it. It's a capacity to do a work, not important. Then we went on further and then we discussed what is an exothermic reaction, what is an endothermic reaction. Exothermic, it's releasing heat which increases the temperature. So any reaction that is increasing the temperature, which makes you feel the heat, that is exothermic. So other way around, if the reaction gains heat, it's going to be endothermic. So those 2 things you need to know. After that, I discussed about a system. So system has components, macroscopic properties and microscopic properties. Microscopic properties can be the properties which cannot be measured directly. Indirectly only we have to measure. For example, kinetic energy of molecules. These kind of things we can't measure directly. The other one is the macroscopic properties. Macroscopic properties we can measure enthalpy change only we can measure. Mass, density, and those things. These are going to temperature. These are going to be macroscopic properties of a system. Color, refractive index. These are macroscopic properties. Then under macroscopic properties, there are two things: intensive properties and extensive properties. So extensive properties and intensive properties. Intensive properties means the properties which do not change with the amount of the substance. Or per mole, per cubic centimeter, per cubic decimeter, density, and then these kind of things. They do not depend on the amount of substance. Then the other one is extensive properties. Extensive properties depend on the amount of substance. For example, mass. They depend on the amount of substance that you take. Then after that we discussed what is enthalpy. Under what is enthalpy we told you. The unit of enthalpy. And what is enthalpy actually? I mean, what is enthalpy? It's the energy stored inside a molecule. It's the energy stored inside the molecule, that is enthalpy. And then I told you we can't measure enthalpy of molecules directly. We can't measure the enthalpy of molecules directly. We have to measure them in a reaction. In a reaction only we have to measure it. Final minus initial. We have to measure it like that. Now I gave you a question which means like, how can we measure the products? How can you measure the enthalpy of products? How can you measure the enthalpy of reactants? I gave you a problem there. So you have to keep thinking about it. How are we going to do that? Then the next one. I told you regarding exothermic reactions have negative enthalpy changes. Endothermic reactions have positive enthalpy changes. So these are the things which you need to know. We'll move on. Next page, calorimetry. Now this is where you will find out finally how to measure enthalpy. This is where you will find out exactly how to measure enthalpy. There is a suggestion like I have to do classes at night. It's not going to work. For 2027 year. It's not going to work because you people are students who don't like to give such an effort. I mean, like staying up whole night to do classes. You can't even stay in the daytime. Look at the participant count now, 15. I told you, right? Maybe because of Ramadan thing, they need to pray. I think that's the reason. But you can't do something like that. So that's the issue. That's the issue. Near in the exam, we can. Near in the exam, but not consistent. It's not good for your health also. I mean, staying up all night and then disrupting your schedule. You have to sleep at around 11 or 12. Sleep for 6 hours and then wake up. And then you can be productive in the whole day. That's how you do stuff. That's how that's how you work. You have to sleep well in order to make your brain work properly. Now, calorimetry. Under calorimetry, first point, inside laboratories, heat changes are measured with a calorimeter. It is a closed container designed specifically for this purpose. First, now, there are two things we need to learn. First one is the heat capacity. Heat capacity is the amount of heat required to increase the temperature by 1 unit. The amount of heat required to increase the temperature by 1 unit. Again, let's say there is one sausages. There's a sausages. So the temperature of this is going to be, let's say 30 degrees Celsius. If you want to increase the temperature of this to 31 degrees Celsius of this sausage, what is the amount of heat you should give? That is heat capacity of sausages. And it's going to be a constant for all sausages on earth. Do you understand what I'm telling? The best example is steel. Let's say steel. It's a property of a metal. It's a property of a metal. Heat capacity is a property of a metal. If the temperature is 30 degrees Celsius, if you want to increase the temperature 31 degrees Celsius, what is the amount of heat that you should give? Maybe this one is 10 joules. This one is 100 joules. It's going to differ depending on the substance which you have. Hari, it's going to depend. It's going to change depending on the substance that you have. Yes. Let's say steel, you have 1 kilogram. The energy needed is 100 joules. Now let's say you have 2 kilograms of steel. Now you need twice the amount of heat, right? So it should be 200 joules. Do you understand what I'm telling? Heat capacity changes with mass. Heat capacity changes with mass. So you tell me whether this is an extensive or intensive property. What is it? Heat capacity, extensive or intensive? Extensive or intensive? Come on, tell me. Heat capacity, extensive or intensive? මොකක්ද intensive කියන්නේ? The properties which do not change depending on the substance. Extensive කියන්නේ which change depending on the substance. Amount of substance. So you tell me whether this is extensive or intensive. Every one of you answer. Shada Amin, you have to think about it again. No, you are correct. You are correct. I was just kidding, okay? Now I give this false hopes for you. I mean, I'm telling you like you're wrong, makes you think again, but still you have to fight me back. Or you have to fight me back telling, no, it's like that. Even if you tell the correct answer, I will be like, are you sure? Are you really sure? Is it extensive? Is it intensive? I'll be asking like that. And you have to fight back telling, okay, it's extensive. You can't change it. So that's going to be a correct answer, right? Extensive is the answer. Yes. Extensive. Yes. Very good. So you understood that thing then. Extensive, intensive properties you understood. That means you know how to tell like, okay, the amount of mass is going to change and then it's going to be extensive. Hurry. Then you can write there the equation. Let's write the equation there. Let's write the equation there. Don't write the sausages and all. You represent heat capacity by C, capital C, which is equal to delta Q, the heat change that occurred. No, don't put the delta one. It's the heat that occurred, Q, divided by the delta theta. That means the temperature change per degree Celsius. To increase the amount by 1 degree Celsius, what is the amount of heat you should provide? That's the heat capacity. Heat capacity depends on the mass. Depends on mass. Depends on mass. So Q is the heat. And then delta theta is the temperature change. Temperature change, people, you can put it in degree Celsius or Kelvin. Now, change in temperature, it's fine. You can put in Kelvin or temperature, degree Celsius. Both are same. For example, let's say 27 degrees Celsius. I'm going to increase it to 37 degrees Celsius. 27, if I convert to Kelvin, it's going to be 300 Kelvin, right? 37, if I convert to Kelvin, it's going to be 310 Kelvin. So the values are different, but the change is going to be equal. Delta theta is 10. Even if you put Kelvin and Celsius, doesn't matter. It's going to be the same. Hurry. It's going to be the same. Hurry. So it depends on the mass. Depends on the mass. That's what's important. Write this equation and explain the terms. This is heat capacity. Depends on the mass. Hurry. Now, if you're attending to the class, if you're attending to my class, people, you need to have a 200-page CR book. You need to have a 200-page CR book near you if you're attending my class to do questions. දැන් ඔයගොල්ලන්ට ටියුට්ස් මොකුත් ලියන්න නැහැ කියන්නේ like පොතේ ලියන්න කියලා එකක් නැහැ. You have nothing to write in separate books, notes and stuff. You have a tute and majority of them are already written for you. We just have to fill the gaps and then you have to understand it through that. So what we write is only questions. What we do is only questions. That's what we write. So make sure you have a separate book for that. Right. Then take out that question book. Take out the question book. If you don't have a question book right now, take a CR paper or something. Take a CR paper or something. Hurry, take a CR paper or something. And then you write this question. Write this question. Roughly write it. Hurry, roughly write it. Steel absorbs 10 joules of energy. Steel absorbs 10 joules of energy. Calculate the temperature change. Calculate the temperature change in degrees Celsius. Within brackets, right? The heat capacity of steel. I'll tell you the exact value, okay? Give me a second. Heat capacity of steel is 460. Not specific heat capacity, and they are telling the specific. Hurry. 460 joule per Kelvin. Steel absorbs 10 joules of energy. මෙතන දාන්න 5 kilograms of steel. 5 kilograms of steel absorbs 10 joules of energy. Calculate the change in degree Celsius. But there are specific heat capacity of the steel is going to be 460 joule per Kelvin. Hurry. 5 kilograms of steel absorbs 10 joules of energy. Capacity is given. Then you have to calculate the delta theta. Right? The temperature change that has occurred. Okay. Do this question. Make a heat capacity of 1 kilogram. This should be heat capacity of 1 kilogram. Now heat capacity depends on the mass. Heat capacity of 1 kilogram of steel. නැත්තම් දාන්නකො 5 kilogram කියලා. 5 kilogram of steel equals to heat capacity of 5 kilograms of steel is equal to 1000 done. 1000 joule per Kelvin. Now easy. So 5 kilograms of steel absorbs 10 joules of energy. Calculate the temperature change in degrees Celsius. Heat capacity of 5 kilograms of steel is 1000 joule per Kelvin. Write it down and do it. Raise your hands once you're done and also send me your answers. Right. One person calculated the answer. Good. Others do it. Yes, correct. Okay, let's see. Vidushi, correct. Divya Darshani, correct. Samha, 0.01, correct. No, 0.01 in Ifa. If I wanted to ask, now I have given there to put your name, right, in the Google form. Say like the name according to the ID card number. Hare ID card එක තියෙන නම. Do you have only that one name in your card? Or else like you have two names and you just put one name. I wanted to ask about that. One person has put only one name. That's what I was thinking. Okay. We'll do this question and then I'll give you a break. That's the big lunch time. Sorry, lunch. It's 8:30 and I'm talking about lunch. Dinner break. Hurry, dinner break. I'll start the class at 9 after I discuss this. So 5 kilograms of steel absorbs 10 joules of heat. So calculate the temperature change. So C is equal to what? Q over delta theta, right? Q over delta theta. So then delta theta will be Q divided by C, which is equal to 10, right? 10 joules divided by C is going to be what? 1000 joules per Kelvin. For 5 kilograms, the heat capacity of 5 kilograms of steel. So that's going to be that. So joules and joules cancel, 0 and 0 cancel. It's going to be 0.01, 0.01. Kelvin Neme will put in degree Celsius because both are same, no difference at all. The change in temperature can be Kelvin and Celsius, both are same. There you go. Okay, 8:37. I'll start the class at 8:57. 20 minutes break I'll give you. 8:57 I'll start the class. Come back at 8:57. I'm going to start the class after the interval. 20 minutes enough, right? 8:57. The class will continue until 10. 3 hours. So come back at 8:57. And remind me to start the recording. Okay, don't leave the meeting. Meeting no use of staying all this time period also. Cover the rest of the stuff. Why break? Then we should give a break to the new students. So these guys are, fresh people, need to give a break in middle and then do the class. Okay, 20 minutes break starting at okay, remind me to start the recording. One of you just tell me, okay? Sometimes I forget to start the recording. Tell you this. I need to tell you this. The people who join new, every month and we have a main exam. So this month also you have a main exam. In the main exam, you write the paper online. Physical students can come and write physically at the institute. Others can write the paper online. And then we are going to mark the paper. We are going to give you the marks. We are going to discuss the paper. And then we are going to upload your marks to the website. And then paper after paper after paper, you're getting a performance curve. Whether you have performed better than the last time or you have performed less than the last time. For example, like this. Main exam 1, let's say here. Main exam 2, let's say here. Main exam 3, let's say here. 4, 5, 6. So you can graph yourself to success. I mean, until the last set of papers, you can graph yourself forward. And then you can check your ranking from the other students. Actually, I have included that in the PDF. I have put a PDF in the group. May the marks analysis system in the website rchem.lk. I'll let you have the access once you pay and join the class later. You can have access for them. So you get a curve like this, which is very interesting, which is not a feature of other classes, which you have it in our class, in the theory class. Hurry. So we are going to start specific heat capacity. So what is specific heat capacity? The amount of heat required to increase the temperature of a unit mass by 1 unit. Of a unit mass by 1 unit. I thought you get an idea. Okay, specific heat capacity කියන්නේ the temperature needed to increase the temperature by 1 unit per unit mass. It can be per gram or per kilogram, whatever. For example, now in the previous example, we took a sausage, right? We heat all 30 degrees Celsius to 31 degrees Celsius. What is the amount of heat required? We told that on as 100 joules. And this one may be around 500 grams. Maybe 500 grams. A big sausage, okay? Giant sausage. Let's say 50 grams. 50 grams. So 50 grams to increase from 30 to 31, you need 100 joules. Right? You need 100 joules. But now what you are telling is we are not taking 50 grams. We are taking only 1 gram. We are cutting it into a small piece. Right? We are taking 1 gram. To increase the temperature from 30 to 31 degrees Celsius, the temperature change of 1 degree Celsius per unit mass, what do you call that? Specific heat capacity. The amount of energy required to change the temperature of 1 gram, not 1 kilogram maybe, from 1 unit of temperature is called specific heat capacity. So this is going to be somewhere around, now 100 is for 50. For 1, it's going to be 100 divided by 50, which is equal to 2. Right? 2 joules of energy is needed. 2 joules of energy is needed to increase the mass of 1 gram from 30 to 31. That means 1 unit you have to increase. So that is specific heat capacity. So the equation for specific heat capacity looks something like this. Q is equal to, S. S is equal to S specific heat capacity is equal to Q, the heat change that has occurred, divided by M delta theta. Delta theta is the temperature change and M is the mass. So M is a new quantity here. I'll put that on as mass. And then S is the specific heat capacity. So specific heat capacity depends only on the type of metal. Specific heat capacity depends only on the type of metal, while heat capacity depended on mass too. And also type of metal is going to differ. Type of metal as well as the mass, it's going to differ, heat capacity. But specific heat capacity, it will change only with the type of the material only. So that's the important point. So normally in this unit, we are using Q equals ms delta theta. We are calculating heat change. We are calculating heat change. So this will be a constant, right? Specific heat capacity will be a constant. Mass will be the mass of the system. And temperature change we can measure using a thermometer. So we can calculate Q using this, right? We can calculate Q using this. Include this one also. So you just cross multiply. Just cross multiply that. So people, Lamai, now we're going to change this equation a little bit. We're going to change this equation a little bit. Read that part. The temperature change can be measured either in Kelvin or degree Celsius because the change will be taking the same value whether it's Celsius or Kelvin. This fact I told you, whether it's Celsius or Kelvin doesn't matter. The heat change for a reaction can be calculated using the two equations given below. Hurry. Now, can I erase the board? Finish writing? Raise your hands. Raise your hands. Nice. If you didn't tell me that, the question which I asked before. ඉස්සෙල්ලා ඇහුවේ කලින් ඇහුවේ. You didn't answer me that. Okay, if you are not confident about that, don't. Hurry. Now listen, what are the two equations which you can use? Now we can use Q equals ms delta theta. People, mass, we can write it in terms of density and volume, right? Density multiplied by volume. What did you ask? You can't remember. I'll tell it later. Hurry. I told it in the class itself. So mass we can write in terms of density and volume. Isn't that right? So we can write it like dV S delta theta. For a solution, we can write dV S delta theta. Q equals dV S delta theta. We are using this in chemistry all of the time when it comes to calorimetry. dV S delta theta. And also when it comes to heat absorbed by the calorimeter, we write Q is equal to ms delta theta. Right? The mass of the calorimeter multiplied by specific heat capacity of the metal of the calorimeter multiplied by the temperature change that has occurred. So we can calculate that also. For this one, you can be using this for the calorimeter. You can use this for the calorimeter. You can use this one for the solution. Write this too. Here in the note, page number 5, middle part, above the question hold one topic. Right. When you're done, raise your hands. And now since new students are joining, the existing students will have new competition in the main exam. So our highest mark was 75 last time. 75 was the highest mark. Hafsa Rizan. The second highest was around 57 or something. So there's a big gap. If someone can score more than this, then she's going to go for the second place. So let's see. So this month, you will also have access for the main exams if you're writing. Any students who want to join new will have access. Hurry. Every month end only we have the exam. Month end, most of the time. Hurry. Right. Question hold number 1. Now we are going to face some questions regarding this question pattern. Look at the first one. I'm going to do it for you. Calculate the heat change that has occurred when 50 milliliters of HCl reacts with 50 milliliters of sodium hydroxide. The concentrations are 0.1 mole per cubic decimeter. That capital M means concentration, mole per cubic decimeter. Okay? The temperature change that has occurred is 30 degrees Celsius. The specific heat capacity of the water is 4.2 joule per gram per Kelvin and the density of water is 1 gram per cubic centimeter. Hurry. Now, write there a statement in red pen or something. With a red pen, write a golden statement there. Write a golden statement there. the density and the specific heat capacity of the solution, the density and the specific heat capacity of the solution, the density and the specific heat capacity of the solution is assumed to be equal to that of water, right? The density and the specific heat capacity of the solution is taken equal to that of water, right? So what does that mean? What does that mean? Now sodium hydroxide and HCl is mixed, right? I mean, when you mix them together, 50 milliliters, you mix them together. Before reacting, I'm talking about, right? Before reacting, 100 milliliters are there. 100 milliliters are there. Even after reacting, you have to assume it to be 100. So volume doesn't change. Right? So when you mix them suddenly, what's going to happen is a reaction will happen. A reaction will happen. Now you're going to put a thermometer inside and measure this reaction, measure the temperature change of this reaction. That's what you can do, right? You can't measure the heat change. Just be honest. You can't measure the heat change of a reaction. What you can do is measure the temperature change. And then we are going to use that equation we learned about to calculate the heat change. Right? To calculate the heat change. So what we can do is now we can apply the equation Q is equal, delta Q is equal to dVs delta theta. dVs delta theta. Density is what I told? Density of water. What is the density of water? 1 gram per cubic centimeter. People, use units definitely. I repeat, use units definitely. Don't just write the equation and just write answers like you're lazy like hell. Don't be like that. Write with units. When you're substituting, substitute with units. First thing is, otherwise you won't get marks. Sorry, my throat went something wrong. First one is you won't get marks. The second one is you will not be able to get the correct answer if you don't write units sometimes. Your final answer could go wrong. You have clearly seen this in unit number 4. 2027 students know this. If you don't write the units, you're going to face an issue. You're going to face an issue and your final answer could be wrong. So to eliminate this issue, we are substituting with unit, and also you don't get marks if you don't write with units. So you have to keep that in your mind. So you have to substitute with units. So is equal to 1 gram per cubic centimeter multiplied by the volume of the solution. What is the volume of the solution? Okay, now I told you, can you remember 1 milliliter is 1 cubic centimeter, right? 1 milliliter is equal to 1 cubic centimeter. Also, I told you 1 cubic decimeter is equal to 1 liter. If you don't know this, write this somewhere. In gases, we use the second one most of the time. In this unit, we are going to use the first one most of the time. 1 milliliter is 1 cubic centimeter. So most of the time, they are going to give you in milliliters. And then you have to write it in cubic centimeters, which is the same thing. So it's going to be 100 cubic centimeters. You don't write 50. That is only for HCl. Before mixing, we have to consider after mixing both of them. So 100 cubic centimeters is what you should put. Multiplied by the specific heat capacity. Specific heat capacity is going to be 4.2 joules per gram per Kelvin. 4.2 joules per gram per Kelvin. You have to write with units. Finally, the temperature change that has occurred, 30. Put here Kelvin, people, because this one is in per Kelvin. So if this is per Kelvin, put this in Kelvin because both are same. Temperature change, it's the temperature change. So I can cut off Kn per Kelvin, right? Kn per Kelvin I can cut off. Then I can cut off per cubic centimeter to cubic centimeter. Then I can cut off grams to per grams. And now what is remaining? Joules. So it makes sense. The heat change that has occurred is in joules. Now we multiply. So 4.2 multiplied by, let's say 100, I get 420. Multiplied by 30, which is equal to 3 into 2, 6, 3 into 4, 12, and 2 zeros, joules. If you want, you can write this in kilojoules, 12.6 kilojoules. 12.6 kilojoules, right? Write this down under the first one. Once you finish writing this, do the second one. Do the second one. Note, Tugish, I'll send you the note after the class. So then why concentration is given? Oh, that's to confuse you. That's to confuse you. The concentration is given for another reason. You will understand that in the next page. Why I have given concentration. Very good question. You notice that. That's so good. You notice that concentration is given, but we are not using that in the calculation. Very good. So we are using something else. We are using it for something else later. I want students like that. I really want students like that. The people who are going to ask questions, the people who doubt, the people who send questions, the people who have a lot of doubts. I like those students. They are the people who are going to score marks. Very good. One person has found the answer for the second one. Yes. Okay, then I'm going to do that. Hurry. So in this reaction, what we have is HCl and sodium hydroxide is the same thing, but the volumes are different. 50 milliliters of sodium hydroxide and 20 milliliters of HCl. So altogether we have 70. Altogether we have 70. And the other things are same, right? The temperature is also same. So the density 1 gram per cubic centimeter multiplied by the total volume 70 cubic centimeters multiplied by specific heat capacity. Specific heat capacity is going to be Same thing, 4.2 joule per gram per Kelvin. Multiplied by the temperature change, which is going to be 30 degrees Celsius. So 30 Kelvin per gram, cubic centimeter per cubic centimeter. Then it's going to be how much? 70, 42. 42 multiplied by 7 multiplied by 30. So 3 into 2, 6. 3 into 4, 12. 126 multiplied by 7 multiplied by 10. 6 into 7, 42. 4 remaining, 7 into 14, 18. 1 remaining, 7 plus 1, 8. 0, 8.82 kilojoules is the answer. Raise your hands if you got this correct. Raise your hands if you got this correct. Come on. Very good. Very good. Nice. So the fact that you haven't done energetics in other classes and you're doing energetics here, you need to know something. We started classes not while other classes started. We started classes when, people tell me, when did you start class? In our class, people who came from beginning, you tell me, when did we start classes? Come on. When did we start classes? Yes, October. We started in October. That's correct. So that's around 5 months late. And now we have caught other classes and then we are passing other classes right now. And we have some stuff to do in Unit 3 and Unit 4. But now I think we have passed those classes. That is accelerated theory, and we are going to finish the syllabus earlier than them by starting late. We also started late, and if you want to finish also early than other classes, that's the goal. This is target. That's the meaning of accelerated theory. So yeah, here we go. And believe me or not, before last week actually, we had only one class per week. Sometimes here and there we have 2 or 3 classes. Most of the time we had only one class. Hurry. Third one, do it. So 50 milliliters of H2SO4 and 50 milliliters of sodium hydroxide. Concentrations are 0.4 and 0.4. The temperature change is 25 to 35. Specific heat capacity is this much. Density of water is this much. Calculate the heat change that has occurred. Good. So this is going to be the same. Volume is going to differ. Temperature change is going to differ. It's going to change. So people, the total volume is going to be 100, right? And the temperature change is 5 degrees Celsius. So I'll write 5 Kelvin. Kelvin per Kelvin cancel off. Then 420 multiplied by 5. 420 multiplied by 5 joules. So find 0, 0, find 2, 10, 1 remaining, find for 20, 21, 2.1, 2.10 kilojoules is the answer. That's 2.1 kilojoules. Correct, right? Find to 0, find to 10, 1 remaining, find for 20, 21, right? Correct me? This is correct, right? Multiplication by the nemator. And at 21, the find 0, 0, find to 10, 1 remaining, find for 20, 21. 2100. You write it in kilojoules, you get 2.1. Hardly? 5 degrees Celsius. 10 degrees Celsius. 10 degrees Celsius. 10 Kelvin. Yes. My bad. That means it's going to be 4.2 kilojoules. Right? 4.2 kilojoules. These 2 zeros and that 0 is going to form kilo. So yeah. One more thing. Outsiders. Dear outsiders. You don't know unit conversions, right? You don't know unit conversions. But our class students know how to do unit conversions, like, converting cubic centimeters to cubic decimeters, converting per cubic centimeter to per cubic decimeter, and then maybe converting per cubic meter to per cubic decimeter, and then maybe sometimes square meter per square meter to per square centimeter. I'll give a recording for this. Now, if you continue the class, I will give a recording for this unit conversion section, which I have done for these guys. And you can cover this part, which is very important for A levels. What important, this section, converting unit conversions from one to another. Very important when it comes to gases, so much important. So in chemistry only, most of the time it's important, not than physics, not much in physics, but in chemistry it's very much important doing unit conversions, especially in units like gases and also chemical calculations. Doing unit conversions is very essential. So in case if they gave the what you call the volume in cubic decimeters, you don't know what to do. Haridanyam, you memorize ne? Be honest, you memorize this, right? Cubic decimeters to cubic centimeters, you memorize this. You memorize this. Isn't that right? We take it from calculation. We take it from calculation. Decican 10 to the power minus 1, so minus 1 to the power 3, right hand side 10 to the power plus 2, plus 2 to the power 3. So 3 into 2, 6, 10 to the power 6, and then simplify with 10 to the power minus 3 all together, 10 to the power 3. Now, I did it in the board and it takes time, but I can do it in my head and then get the answer directly 10 to the power 3. Doesn't even take 2 seconds if you develop the skill. I don't know, initial phases, it might take you some time to do calculations, but when you go further forward, you will have the, what you call, you can do it by just thinking about it. Calculation it's like, in small days, we added 5 and 6 like this. We added 5 and 6 and then we took 1 to the other side and then we wrote 11. But now we can do 5 plus 6 easily, right? So that's the difference. So unit conversions also same. Then, now what is important is the next one. Calculating enthalpy change from heat change. Calculating enthalpy change from heat change. Consider the question 3 above. Okay, I have given the same question again. Okay, we have calculated the heat change of this reaction, which is 4.2 kilojoules, isn't it? Which is 4.2 kilojoules. This is the answer for that question. So this is the heat change that has occurred. In order to calculate enthalpy change of the reaction, we have to first identify whether it's an exothermic or endothermic reaction. You tell me. Exothermic, raise your hands. If the reaction is exothermic, raise your hands. If the reaction is exothermic, raise your hands. Come on. Come on, raise your hands. If the reaction is exothermic, I mean the third question, this question, if the reaction that is happening is exothermic, raise your hands. Exothermic, huh? No. Okay, endothermic, raise your hands. If the reaction is endothermic, raise your hands. If the reaction is endothermic, raise your hands. Seriously? You have to do this to me right now? Not a single person raised their hands when I asked exothermic. Seriously? Think. Think again. Think again. What is exothermic? Ayyo, ayyo, ayyo. Okay, again, I'm going to ask the same question. Is this reaction exothermic or endothermic? The reaction between H2SO4 and sodium hydroxide. Exothermic or endothermic? Exothermic, raise your hands. Exothermic, raise your hands. Exothermic, raise your hands. Seriously? Are you playing with me or something? Okay, one person. What's wrong, man? Exothermic. Come on, guys. This is exothermic temperature increase given in the question itself. Change from 25 to 35. Exothermic. Exothermic. Now raise your hands. Is the reaction exothermic? Raise your hands. Is it something like, inside your mind, like if it's exothermic, I shouldn't raise my hands or something like, raise your hands, come on. Anna. Everyone, come on. Be active, be active, be active. Be active, be active. Everyone raise your hands, be active. Every one of you raise your hands. Raise your hands, raise your hands, raise your hands. Raise your hands. Ifasa. Okay. Exothermic. Exothermic the delta H is going to be what? Negative, right? We talked at the beginning. Delta H is going to be negative. Make a balanna. If exothermic, you can calculate the delta H. Delta H is equal to minus Q. Now minus Q can look at this one. Divided by number of moles of the limiting reagent that is reacting. Number of moles of limiting reagent. Moles of limiting reagent. I hope you know unit 3. Limiting reagent. The person who is going to react first and finish. Hurry. You remember that burgers and sandwiches video I uploaded in YouTube? I'll send that to you. How to calculate limiting reagent? Moles of the limiting reagent. That means the first one who is going to react and finish. The first one who is going to react and finish. That is the limiting reagent. So we put this negative by hand. We put this negative by hand. Like manually we are going to put it. If the reaction is endothermic, we don't put it. Do you understand? So delta H, we have to use this equation now because this reaction is exothermic. The temperature has increased. So the answer will be minus 42 kilojoules divided by number of moles of limiting reagent. You have to calculate that. How are you going to calculate the limiting reagent? 2027 students who have already attended the class. What are we going to do? Write the reaction. First thing, write the reaction. Second one, what? Balance the stoichiometry. Third one, what? Find the number of moles of each reactant. Fourth one, what? Divide by the stoichiometry, right? There are 5 steps. Write in the reaction H2SO4 plus sodium hydroxide. You react to form Na2SO4 plus 2H2O, right? So it's going to be 2NaOH. So 1:2 ratio, stoichiometry. Now what you do? You write the reaction, you balance the stoichiometry. Third one, you need to calculate the number of moles of each component. This one and this one. You have to calculate the number of moles of each component. How are you going to calculate that? You're going to multiply the concentration by the volume. So the concentration is given here, 0.4. 0.4 mole per cubic decimeter multiplied by 50 10 to the power minus 3, right? 50 10 to the power minus 3 cubic decimeters. So cubic decimeters per cubic decimeters cancel off. It's going to be 0, find for 20. 20 10 to the power minus 3 moles. That is the number of moles of H2SO4. 20 10 to the power minus 3 moles. That's the number of moles of H2SO4. That is why I gave concentration. One student asked me why I gave concentration, and this is the reason. Calculating the moles of each reactant that is reacted. This one also same. 50 milliliters of sodium hydroxide is reacted. So that means what? Same thing, 50 10 to the power minus 3 multiplied by 0.4. That's going to be how much? 20 10 to the power minus 3 moles. That is the moles of NaOH that is reacted. Now, who's the limiting reagent? Who's the limiting reagent? Tell me. Who's the limiting reagent? Sodium hydroxide or H2SO4? Who is the limiting reagent? Tell me, tell me, tell me. Right. Others? Tell me, quickly. Come on. Who is the limiting reagent? You divide by what? What's the shortcut I told you? Yes. How do you do it? You divide the number of moles which you get by the stoichiometry. So 20 divided by 2 is going to be 10 into 10 to the power minus 3, right? And then this one, 20 divided by 1, which is 20 10 to the power minus 3. The lesser value will be the limiting reagent. That means sodium hydroxide will be the limiting reagent. Right? Sodium hydroxide will be the limiting reagent. That's how you take the, yes, that's how you take the limiting reagent. We just divide by the stoichiometry. We calculate the number of moles. There are enough MCQs in past papers related to this. All we have to do is calculate the number of moles of each reactant, divide by the stoichiometry, and calculate who's the lesser number. That is going to be the limiting reagent. No need to think much. No need to do some big mathematics here. Just that is enough. 35 minus 25 is plus 10a. So it's end of the, 35 25 කියන්නේ මොකද්ද ඔය temperature change, right? Temperature, I didn't tell temperature change. That's different. Temperature increase කියන්නේ what will happen? It's going to heat up the beaker. Don't think like that. Think you're doing it in a lab. Think like you're doing this experiment in a lab. The beaker is going to heat up. The temperature increase. Exothermic energy is released out. Do you understand? The plus or minus is not determined by the temperature. Plus or minus is not determined by the temperature. That's the biggest mistake you can do. The sign is decided by us, by thinking. We put the negative by hand. We put the negative by hand, not the temperature change. Not the temperature change. You can have temperature decrease and it's not negative. Let's say temperature decrease from 35 to 25 now. Temperature decrease, you might be wondering 25 minus 35, it's negative. So the reaction is exothermic. Think logically. Temperature decrease it's cooling down. That means the reaction is endothermic. Reaction is absorbing heat. So now what? Even though the temperature becomes negative, we ignore that sign. We don't put that. We only take the change in temperature as a modulus value. Modulus we don't take the sign. We just put a positive thing. Do you understand what I'm telling? Raise your hands. If you understood that, raise your hands. Every one of you. So if endothermic reaction absorbs heat, it should has more energy. So why is it not hot? It is changing the energy into another type of energy. Yes, very good question, Mohammed Ahmad. Very good question. That question, I like that question because that student asked me, if the reaction is absorbing heat from outside, why doesn't the temperature increase? The heat is absorbed not to store as heat. It is going to store it as chemical energy. These reactions are happening to arrange into new forms. For example, this reaction, H2SO4, the bonds are breaking, people. Hydrogen and oxygen bonds are going to break apart. Sodium and oxygen bonds are going to break apart. Ionic bonds broken. New ionic bonds are formed. New covalent bonds are formed. Water is formed. Different interactions are going to form. This kind of energy is stored as chemical energy and not as heat. Do you understand? So when this reaction is complete, if there is excess heat, it's going to release out. So that is going to heat the beaker, and that's exothermic. Do you understand what I'm telling you? Akmal, come on. Drop your message. Did you understand what I told? Yes. Very good. So that is what I mean. So number of moles of limiting reagent will be the one who has a lesser number, and that's going to be sodium hydroxide, which is 20, 10 to the power minus 3. Right? 20 10 to the power minus 3 is going to be the limiting reagent. 20 10 to the power minus 3 moles. So when you simplify this, you're going to get an answer. 42 divided by 20, that's 2.1 minus 2.1 into 10 to the power 3 kilojoules per mole. Kilojoules per mole, right? So this is not per mole, this is moles. So that's the answer which you're going to get. 2.1 into 10 to the power 3 kilojoules per mole. So that's going to be 2000 minus 2100 kilojoules per mole. That's what you get. Right. The value is correct, right? I took it correctly. 15 to 0.4. 50 into 10 to the power minus 3 into 0.4. How 5 into 4, 20, 20 to the power minus 3. Hurry. Hurry. So that is that. That is how we do these calculations. Now look at the next page. Look at the next page. I'm going to give you a 5 minutes break. I'm going to give you a 5 minutes break. 9:42. 9:42 I'll start. So after this chaos, you should have a small break. And then after that, we'll complete this part and do some questions. So the rest of the stuff you can do as homework, right? So we'll start at 9:42. Okay, I didn't wish you, right? How to wish Ramadan? Ramadan Kareem, right? Something like that. So Ramadan Kareem, everyone. I don't know. I'm Buddhist. I don't know how to wish. Okay, so apologize me if I have told something bad. That's how to wish, right? So can we access previous recordings of previous lessons? Actually, no. This month recordings you can access, but you have to make a full payment for that. If you want this month recordings, previous class recordings, this month recordings are, I mean, not worth it to get, but because like we have done from the middle of unit 4 and unit 3. That's why I told half payment for the rest of the energetics and inorganic. Like අපිත් එක්ක energetics inorganic කරගෙන යන්න. හරි ඒක තමයි මම කිව්වේ. අර අනිත් units ටික නම් කරන්න විදිහක් නැහැ. I won't be able to give them because they are expired already. So there's no way of getting them back and I didn't upload to YouTube some recordings. It just expired. Hurry. So sometimes I just uploaded it to the website and then it got deleted and I didn't upload to YouTube. And that's the reason. අපිත් එක මේ ටික කරගෙන inorganic energetics from that point onwards we'll move forward. And this week, the other date, I'll decide whether I'm doing energetics or I'm doing unit 4, unit 3. හරි? මට unit 4, unit 3 complete කරගන්න. I need to complete unit 4 and unit 3 before this month ends. So I might do unit 3 and unit 4 this weekend in the weekend class. So if you're located in Kandy, why don't you come physical? Come physical. Hurry, I invite you to come physical. Better place. Okay, then we are moving on now. 9:42 and 9:41 now. And 9:42. And I will also be starting classes in Colombo, 2027 Theory Colombo. I'll be starting. Can't we join only for energetics? එහෙම බෑ ඉතින්. There is no, this is not a bus hold or something like go to only one place. එහෙම බෑ. It's a trip around the country. If you want to join the trip or else you can stay away. We can't join only for one session, one class. එහෙම බෑ. Not only for one unit. If you want to join, if you don't want to join a theory class, then you join for theory. Otherwise, you can wait until I start revision class. You can join my revision class if you want only energetics. Revision class එකේ අපි energetics, organic ඔක්කොම කලවමේ කරන්නේ. හරි, it's revision. So why don't you want to do inorganic? Come on. Inorganic is the most famous thing I teach. If you don't know, you can ask revision students about it. They have completed inorganic S&P block. Hari. So next page number 7. During experimental procedure, we use a plastic calorimeter. I'm already in a project. What do you mean project? What do you mean in a project? During experimental procedure, we use a plastic calorimeter to find the enthalpy change. So this is something which you see in essay questions of energetics. They are asking you, why is plastic calorimeter used than a metal calorimeter? So that's we had right reasons for that, right? So first one is like plastic is a good heat insulator. Plastic has low specific heat capacity, easy to use and cheap. Like plastic cups can be found everywhere. So these are the answers which you can write for that. Not using a metal calorimeter, right? You can write them in the exam. So there you can see how the experimental procedure is carried out. Beaker is there 250 cubic centimeters, and then there's a plastic cup put inside it, and there's a thermometer, and then there is what you call decama thermometers. Both can't be thermometers, ne? One is a stirrer, one should be a stirrer, and the other one should be a thermometer. And then there's the plastic cup and the cover is there. So this is a closed system. We are assuming it to be isolated system. Plastic is harmful, but you're not throwing it, right? Oh, they do classes for all the subjects in one place. Like, I don't know. Yes, I have seen that. In hostels and all, like, I mean, in schools, I have seen that's happening. Yeah. You can continue with them, no issues. Right. Question hold number 2. Assume density of the solution is 1 gram per cubic centimeter, and second one, specific heat capacity of the solution is 4.18 joule per gram per Kelvin, and then no heat loss to the surroundings. Right. First one, let's do. What are they telling? 0.1 moles of anhydrous calcium chloride was added to 150 cubic centimeters of water in a plastic container, plastic cup. The maximum temperature increase was found to be 7.2 degrees Celsius. ඒ කියන්නේ temperature එක 7.2කින් වැඩි වෙලා increase by 7.2. The change is 7.2 and it's increase. Increase කියන්නේ මොකද්ද? Exothermic or endothermic? Raise your hands if you are telling exothermic. Raise your hands if you are telling exothermic. Come on. Good. Exothermic, right? It's going to be exothermic. So calculate the enthalpy change that had occurred. So let's calculate that. So calcium chloride is going to react with was added to water. Okay. So this is, calcium chloride solid. One more thing, when you're writing reactions, people, you have to put the states, whether they are solids, aqueous, or liquids, you have to put the states. That's the rule of physical chemistry. In physical chemistry, you have to put units. So calcium chloride solid will go to calcium chloride aqueous. We write this like this. This is hydration. This is hydration enthalpy. So you're going to learn that later. Types of enthalpy changes you're going to learn later. In this tute, you have it actually. Before the end, you have it. standard bond dissociation enthalpy, standard neutralization enthalpy, standard first ionization, and then standard, what do you call, everything you have, solvation, hydration, dissolution, fusion, atomization, and combustion, everything is there in this tute. So, yeah. So we will 0.1 moles of anhydrous calcium chloride. So the number of moles reacted is 0.1. You have to note down the information they have given. Was added to 150 cubic centimeters. So the volume is 150. And the temperature change is 7.2. So delta theta is 7.2. Kelvin, no degree Celsius. Both are same. Hurry. Now what we can do is we can calculate delta Q. We can calculate delta Q by dVs delta theta, right? So dV density is going to be how much? Density is going to be 1 gram per cubic centimeter. So 1 gram per cubic centimeter multiplied by volume. The volume 150 cubic centimeters multiplied by specific heat capacity 4.18 joule per Kelvin per gram multiplied by temperature change 7.2 Kelvin. Hurry. Per Kelvin, Kelvin cancel off. Per cubic centimeter cancel off. Grams and per grams cancel off. So that means you're going to get 41.8 multiplied by 7.2 multiplied by 15 joules. You're going to divide this by the number of moles that is reacted, right? Delta H is equal to the what do you call, the heat change that has occurred, 41.8 into 7.2 into 15 joules divided by number of moles that is reacted, 0.1 moles. So your answer, when you simplify everything, 7.2 multiplied by 15, 5 into 2, 10, 1 remaining, 5 into 7, 35, 36, 2 and 7. Right, so 0, 8, 10. So 108 kilo NA. 108 multiplied by 418. 8 into 8, 64, 6 remaining, 6, 8 into 1, 8, 8, 0, 1, 8 into 4, 32, 3 remaining, then 3 here, then 4 into 1, 4. So altogether 4, 8, 6, 14, 8, 9, 10, 11, 1 remaining, and 3 and 1 is 4, 4 and 1 is 5, and then 4. So 4,514.4 then. 4,514.4 joules per mole. So that's going to be 4.52, 4.51 kilojoules per mole. That's the enthalpy change that has occurred. Now I have done a mistake. This answer is wrong. This answer is wrong. Why is that? 150. 150, yes. 150. Why is this answer wrong? You can tell me using your logic, why is this answer wrong? Why is this answer wrong? Any geniuses in the class? Tell me. Yes. Any geniuses in the class? Shada, you're correct. Tell me, why is this answer wrong? It's not related to calculation. If my calculation is correct, if calculation is wrong, keep that aside. I'm asking, why is this answer wrong? There's something else. What is it? Other than calculation errors, there's something else. Anyone who can tell that? Anyone who can tell that? No one. Another person told. No, not water. No, not water. Not water. Not water. There's nothing to consider about water. Yes. Another person told the answer should be negative. People, delta H is negative here. Why is that? The reaction is exothermic. Temperature increased by 7.2 degrees Celsius. So negative. It's exothermic. So we have to put a negative by hand. So that's a very famous kind of mistake students do in these type of calculations. You have to put here negative because the temperature is increased. So notice that once you finish the question, you have to look into that whether the reaction is positive or negative. Yes. Write this down. Hari, now I have done one question for you. I wanted to do the rest of the 3 questions as homework. Right? I want to do the rest of the 3 questions as homework. So in the next class, we are going to do Lavoisier-Laplace law. And then after that, we are going to do types of standard enthalpy changes. First on standard enthalpy of formation, followed by question hold number 3, and then standard enthalpy of combustion, and then solvation, hydration, dissolution, sublimation, evaporation, fusion, atomization, crystallization, electron gain, dissociation enthalpy, neutralization enthalpy, and bond dissociation enthalpy. So there are 14 enthalpies you need to learn, followed by 2 question holes, and then there is a set of MCQs. MCQ run is there. So should we send the homework to you privately after completing it? If you can send it privately like that, good. It tells me that you have done the homework and you are interested in doing this. So I would give you more attention than other students. So something like that. Again, like, එහෙම කරනවා නම් හොඳයි. ඉතින් like it makes me feel like you're working. That's what should happen. That's what should happen. It's not showing off. Yeah, some of you might think like doing the homework and sending to your teacher is showing off. No, I don't think so. Show off. It's okay. Just show off. It's your life. You show off. You just completed something and then you show everyone. I did it. Isn't that what should happen? People are scolding that we show off the things we do. Who cares? People put it status. Who cares about what others think? Just show off. That's my idea. I buy something, I put it status. If it's something very big for me, I put it status. Show off. It's fine. It might make other people jealous. That's why they have to fix the eye which they are looking at. That's the issue. Hari, ඒක තමයි. Now, if you buy a car or something, put it status. If you buy a house or something, put it status. If you buy a new thing, put it status. If you want, Hari, if you want. I'm not telling you to forcefully do it. If you feel like you want to show it, then just do it. Don't think like others will, think about yourself being showing off. That person is showing off. Let them think. Let them think. It's their mind. They should have something to think also. Hari. So I told you I'm going to tell you regarding some study tips and how to balance everything. So there are 11 students in the meeting. I'm not a student, so there are 12 altogether, including me. Hari. So I'll give you something to do within this week. I won't give you long-term plans, motivation, I'll give you something to do within this week. I'll give you some upliftment strategies for you in all 3 subjects. I don't know about mathematics. I haven't done maths. I have done bio. So I'll tell about bio, chemistry, and physics. Okay. Study 90 hours in this week. Study 90 hours in this week. 90 hours in this week, including class time. Including class time, 90 hours. You can do that, right? You can do that. So that's the first thing. You have to divide equally to 3 subjects, 30 hours each. 30 hours for each subject. Don't unbalance them. Do 30 hours for each subject. So this can include revising time, homework time, self-studying time, questions answering time. Maybe you can answer a past paper question. Now you can do structured essay questions. 2027 students, you perfectly know that you can do structured essay questions right now. We did 2017 in the class. I wanted to do other past paper questions from 2016 to 25. Do them everything. Do all the structured essay questions. Have some time to do structured essay questions. At least one a day, do it. One a week. Sorry, once a week, do a structured essay question. හරි ඊට පස්සේ you can revise and then go to classes. Class time also include in this 90 hours. Second one, use pomodoros. I know some people are there who can't score more than 40. මේ level එකේ ඉන්න කට්ටිය ඉන්නවා in this meeting, the people who are scoring around 40s. You guys cannot sit in one place and study for long amount of time. You will definitely go and grab your phone. So you can't sit in one place and focus. Either you will think of someone else or something or මොකක් හරි එකක් හිතනවානේ. වැඩකට නැති මේ ලෝකෙට වැඩකට නැති එකක් හිතනවා. Your mind will go to those things. It's the monkey mind. You call that the monkey mind. There's the monk mind and there's the monkey mind. Monkey mind only goes to different places and thinking about this, thinking about that, negative thoughts and everything comes. Your brain is uncontrollable. It's like a monkey jumping from one tree to another, from thought to thought, chasing behind something which is very useless for you. That is how you study, monkey mind. So you have to control that monkey by using pomodoros. You tell your brain, okay, you don't have to focus for 1 hour, 2 hours, 3 hours. Just focus for 15 minutes. Start with 15 minutes. 15 minutes, start a timer, and then don't touch your phone after that, of course. Set a timer for 15 minutes, and then you study for 15 minutes, and then you, when the timer hits, and then you have 5 minutes break, just like how we did the class today. Right? You can use that Pomodoro within this week. Third one, I need to tell you, now first on this 90 hours, then Pomodoros, and then තව කියනවා නම් maybe you can do MCQ reviews. For this week, I'll give you these 3 tips. MCQ reviews, including Pomodoros, and then 30 hours per subject per week you can do. Correct? Okay. And one extra tip I'll give you. Fourth one. Sleep 6 hours. That's it. Every day, sleep at the same time, wake at the same time for 1 week straight. Let's say you can do it. Sleep at same time, wake at same time. If you have Ramadan or something like that, adjust according to that. It can be 6 hours for some people 5 hours. ඒක සමහර කට්ටියට වෙනස් වෙනවා. ගොඩක් කට්ටිය මේ සමහර කට්ටිය ඉන්න some people are there, they are sleeping 3 hours and they're completely fine. That's genetics. That's that's coming with their DNA and how their brain works and stuff. ඒක වෙනස් වෙනවා. From person to person, it's going to change. So sleep 6 hours and then you can decide when to wake up, when to sleep. So every day sleep at the same time, wake at the same time. Once you do this for 1 week, you will feel the 8th day, you will feel so fresh to wake up. And when the time hits, let's say you sleep at 11 every day, when the time hits 11, your body starts releasing all these hormones needed for you to sleep. So suddenly now you're ready to sleep. You will immediately will fall asleep once you come to bed, and then there is no rolling in the bed, and there is no sleep paralysis or anything won't come. So you sleep at one time, wake at one time, continue that for 1 week. Hari? ඒ ටික කරන්න. හරිද? හරි? ඒ ටික කරන්න. This four is enough, right, for today? So in the other class, I'll tell you the rest. Okay, then thank you for joining, especially the outsiders. Thank you for joining today. I really appreciate your efforts staying until the end. At least 11 students stood until the end. Others want to watch recordings and fine. That's also fine, no issues. So, right. You can leave the class now. Next class, we have it on Sunday night, 7 p.m. Okay, don't forget the time. Sunday night, 7 p.m. And I'm not doing the class in front of the whiteboard. I'm going to do the class in the tab I'm going to do screen sharing method. So sometimes it might be boring for some people, but that's how we do the class. The second class of the week, we do it like that. First class of the week, we do it in front of the whiteboard. So next day, you won't see my face. Next day, you won't see my face. You will only hear my voice and the screen. Some people might like it. There are some students who like that. There are some students who hate it, but you will have to get adjusted to both because we are doing it half-half. Hari. So, right, you can leave the meeting now. Thank you for joining and good night. Candy class will start and end Thursday afternoon 3 to 6. Thursday afternoon 3 to 6 and Saturday 12:30 to 3:30. So 2 classes you have, Thursday afternoon and Saturday afternoon. Okay. Good night.